I'm Greg Epple. You've joined MGT301, which is cut through the chaos, gain operational visibility and insight. Thank you for attending and for joining me for the next hour here. So I'm the global solution architect for observability. So what that means is I basically work with customers around the world, focusing on CloudWatch and Xray monitoring and observability. I'd please ask you hold any questions you have until the end. There'll be some time. I'll go down here and we can take questions one-on-one. Just some housekeeping items. We have some other related sessions that you can attend as well. The ones in yellow with my picture next to them are the ones I'm leading. So we actually have a workshop tomorrow that's going to MGT306 that will cover all the stuff I covered today, but you'll get hands-on with the features and the capabilities I'm going to demo. Pretty simple agenda. There's going to be a very extensive demo as part of this presentation, so I'll be doing quite a bit of demoing here. It's going to be pretty rapid fire. There's a lot of stuff that the teams have launched in the last few weeks. But we're going to do a quick introduction, tell you a bit about myself. We'll go into monitoring and observability concepts. We'll talk about how observability on AWS works. Then we'll get into the demo and we'll talk about next steps. So just a bit about myself. Like I said, I'm the global solution architect for observability or CloudWatch and Xray. I've been at AWS for 3 years. I've been using AWS for over a decade now, so I still remember the time where we could fit all our services along the top on the tabbed interface. That doesn't work so well anymore. I started my career as a developer about 15 years ago, so I'm a .NET. I started as a .NET developer. Almost as long as that, I've also been in an operations role. I've always worn both hats. I've had to maintain the systems. I've been an architect, an engineer, and an SRE throughout my career. And then prior to AWS, I was the chief technology officer for a SaaS company as well. So I was, in many of your shoes where you are today, operating, building applications, and architecting them on AWS. So let's talk about monitoring and observability. Who's heard of the term observability? Okay, so about half the room. How I would define observability is how you monitor things, right? Monitoring is the collection of things, of data, of telemetry. Observability is a property of a system, and we'll get more into that. But let's talk about the chaos first, because that's the title of this talk, Cut Through the Chaos. I'm going to talk about a scenario I've been in myself when I ran the SaaS company and we had to operate. I was really the operations guy, the engineer, lead engineer, the CTO. You often come in, if you've had to ever operate software, you come into the office with the best of intentions. I call this blissful ignorance. You're hoping you're going to get through your laundry list of items, you get through your email, you just have all these plans to get all this stuff done today. And usually just before you even get your coffee, an alert goes off, an alarm goes off. And I don't know about you, but when an alarm or an alert goes off, it never tells me exactly what's gone wrong. I don't know if this is a false positive or what the heck's going on. So that alert goes off. There's chaos. Time passes by. Now you start to get stressed. What's the user impact? What's happening to the system? Initially, you do some investigations. You get some false hope. You think you might know what's going on, and you come up with a fix. You put that fix into place. Fix doesn't work. Now you're desperate. So you've come into the office, hoping to get all this stuff done, get your coffee. This alert's gone off. You've gone from confusion to stress. Now you're just desperate. You don't know what's going on. Eventually, you do find the root cause. Maybe it's you, maybe you bring in other teams to help you, but you find the root cause. And you get some enlightenment. And hopefully, you actually create a feedback loop here. You take that, you feed it back into a wiki or a run book. The worst situation to be in is to have an issue occur and just say, oh, it goes away in about 30 minutes, and that just keeps happening and happening and happening, and you never find the root cause. That's a really bad situation to be in. So hopefully you've taken that alignment and fed that back into your processes. And you get to a state resolution. You're making money again with your application. The reason I talk about this or I show this, there's a lot of chaos within this. I'm going to show you tools to help you cut through that chaos. But the other point of this is, in my opinion, I don't think we'll ever get away with having to go through this process, right? Developers will never write perfect code, will never have perfect applications that never have errors. So the question then becomes, how quickly can you get through this? And it's often tied to something called MTTR, mean time to resolution. How quickly can you go through an event? And so you can monitor a lot of things, and I've been in that situation. You could get lots of logs, lots of traces, lots of metrics that doesn't necessarily help you get through the cycle. It's an observable system that will help you get through the cycle. The other thing we have to talk about before we jump into the AWS services and capabilities is monitoring really needs to evolve. I've been doing development for over 15 years. How we developed applications is fundamentally different now than it was what we did 10 years ago, right? User experience is king. User experience is number one. It's hard to understand what the user experience is in microservice architecture. When you have hundreds of microservice components, how do you know what's going on? When we had our monoliths, we would have a database server, we'd have a web server. You could log in and just look at that or look at the load balancer if you had multiple web servers. It was really easy to understand the user experience. Our resources are a lot shorter lived now. They're a lot more ephemeral, right? So if I go back 10 years ago, when I was developing software, I would be deploying maybe on a VM, maybe on bare metal. I knew that would exist for months, if not years. If I had to go look at the logs, I just remote desktop in. Now we're dealing with serverless Lambda functions that exist for microseconds. We have containers that exist for minutes. So what happens to all that valuable monitoring data when that resource actually goes away? Third, we have more devices generating more data. 10 years ago, when I had to monitor and manage applications, I could just go into the Windows box, look at my .NET app, look at the event viewer, and scan through that, maybe do a search. Now we have hundreds, potentially thousands of serverless functions, containers. So how do you actually aggregate all this to a place where you can actually see this? You can't do this. It's not human. One human can't do this manually anymore. And most importantly, in my opinion, is there's a faster release velocity, right? I remember deploying once a quarter. And you do one deployment, you'd plan probably for 2 weeks. Up to that point, you do the deployment. Sure enough, the next day, things break. And you know exactly what caused it. It was that quarterly deployment. Well, when you're deploying 5, 6, 10, 100 times a day, how do you know what has caused an issue when you have an operational event? So these are all the challenges with more modern applications and microservices. I'm going to show you some of the tools. Again, it just creates more chaos that you have to sift through. I'll show you some of the capabilities the CloudWatch and Xray team have released that really help you cut through that chaos. So I mentioned earlier, monitoring is all those things that you do to get monitoring data. So that's metrics and logs, which hopefully most of you guys have heard of. Traces, I think, are a lot newer and folks aren't as familiar with them. You think of logs and metrics, those are very system-centric. They're attached to a system. It could be a container, it could be a Lambda function, it could be a COT solution on-prem. Those are very system-centric. A trace is fundamentally different. It's user-centric. So you could think of a trace as basically a way to encode a user flow. A user hits an endpoint, a bunch of things happen, a response comes back. That whole path, that whole flow is one trace. So trace is encoding a user path or a user flow through a system. So these are all important individually. I would collect all three of them. They'll help you, they'll help your operational stance. But where it's really powerful and where you really get observability is being able to collect all three and correlate them, right? This is actually really, really difficult. How can I look at a dashboard and look at the metrics and see the logs and the traces that are correlated with those? And to actually map this to AWS services, this is what that would look like. We have Amazon CloudWatch logs, Amazon CloudWatch metrics, and AWS Xray providing the capabilities to give you that observability on AWS. And the one thing I would point out too, a lot of folks don't realize this, these tools work on-prem. Xray works on-prem. You can install a CloudWatch agent and put it on-prem and collect this data. So observability is the goal here, and it's not just confined to AWS. You can do this on-prem, you can do this in other places. So, observability on AWS. And before we get into this, I want to just put one stat up here that we released last year, October 2018. Amazon CloudWatch monitors 1 quadrillion or 1,000 trillion metric observations every single month. We trigger more than 3.9 trillion events, and we ingest more than 100 petabytes of logs. And the reason I share this is, just to communicate that CloudWatch really is a hyperscale, a cloud scale monitoring and observability service. And let's talk about CloudWatch and Xray, the breadth and the depth of the platform as well. You can think of both these services along these 4 categories. We have the collection, the monitoring, the action, and the analytics or the analyze. So the collection, these are some of the more recent features that we've launched, such as metric filters, support for statsd and collectd within the CloudWatch agent, and support for AWS Private Link. From the monitoring pillar, we have cross-account, cross-region dashboards, which I'll be covering in my demo, automatic dashboards, metric math, and SQS and SNS support for Xray. For the action, we have synthetics, anomaly detection, which was released earlier this year, as well as metric math, alarms, and analyze. So service lens, this is what's just launched, contributor insights, container insights, which was launched in preview over the summer and went GA later on in the fall, log insights, which was actually released last year at reInvent, and we have Xray Analytics. So we continue, the service team continues to invest in these areas across this whole spectrum, but we're heavily focused on the analytical capabilities. So if you looked at CloudWatch 2-3 years ago, you need to take another look now because there's a lot more capabilities, especially within the last year, really focused on the analyze piece there. But we're investing across the whole spectrum. So these are some of the more recently launched services, capabilities within CloudWatch and Xray. So we have Service Lens, Contributor Insights, Synthetics, Cross-Account, Cross-Region Dashboards, and Embedded Metric Format. So we've launched all these quite recently, usually most of these within the last few weeks, or at least since the fall. And so I'll dive into each of these just really quickly, and then we'll switch to the demo. But Service Lens, if you haven't taken a look at it, you could think of this as it helps you visualize and analyze performance and availability of distributed applications. So microservice architectures, distributed applications, this will help you identify the performance and the availability of those services. Contributor insights, this will really, again, I'll do a demo of this as well. Everything I put up on the screen I'll be demoing. This will help you quickly assess the scope of an event and identify top contributors. If you've ever heard of the term high cardinality, that means that you have a lot of things to look at, right? So imagine IoT devices. You could have hundreds of thousands of those in the field. Web server logs are an example of high cardinality. There's billions of IP addresses, right? So when you have high cardinality, you can't put that on a widget on a dashboard and look at 100,000 things. It's just not possible. So contributor insights will help you identify top contributors within high cardinality data. We have synthetics. So this will help you set up what we call Canary tests, and this will actually simulate a user, and we'll go and test for broken links, page load errors, load latency. It will actually even go and do very complex flows such as wizard or checkout. So if you have an e-commerce site, you can set up a synthetic test that will basically buy something on your site, add to the shopping cart, and go through that whole process and take screenshots along the way. Two more features here. So cross-account, cross-region dashboards. So this will help you it provides cross-account, cross-region visibility of your dashboards and alarms and metrics. And so why this is important is we're continuing to see more and more customers build multiple account architectures with things like landing zone and control tower. When you have, you as an application owner will typically own your account. You'll own the resources within that account, but you usually have a dependency on something else. Maybe it's a shared service account that has transit gateway in there. You may not control that transit gateway, but you want to see some metrics associated with it. So cross-account, cross-region dashboards will allow you to take that data, that telemetry, and put it onto your dashboard from a completely different account. And lastly, we have embedded metric format. So this was also just launched quite recently, and effectively this works quite nicely with contributor insights. So it works on logs, but what it allows you to do is it allows you to ingest high cardinality metric data as a log, and then tell CloudWatch to say, I want to store this as a log, so I can query on it with log insights, but I want to turn some of this data into an actual metric. And you don't have to call put metric data APIs. You don't have to convert that. You're simply defining the structure, and we'll do it for you. So let's do a demo. And it's quite a long demo, so I want to go through and tell you what I'm going to show you. So you know I have a little bit of a path. You'll see the path I'm going to be taking here. So we're going to do this demo from the perspective of this is the day in the life of a SRE role or operations person. Some of this stuff I'm going to have to just simulate because we don't want to sit here and wait for an alarm to trigger and that sort of thing. So I'll have some short things I'll copy and paste. But the first thing we'll do is we'll configure and receive an alarm with dynamic thresholds. If you think back to that circle of chaos there, when the alarm goes off, it's really hard to tell, is this a false positive or what's going on? Oftentimes, alarm thresholds are very hard to manage, right? Because as your usage grows, that threshold becomes irrelevant, you need to update it. So anomaly detection can really help reduce those false positives. Then we're gonna talk about how you can monitor, when that alarm goes off, we have to identify or analyze what the scope of this event is. And so we'll show how you can use cross-account, cross-region dashboards to look at resources outside of just our account that has our application. Then we're going to dive into CloudWatch. We're going to visualize the service performance. So after looking at the dashboard, we'll realize that there's an issue within our application. It's not an external dependency in another account. So we'll use CloudWatch Service Lens to dive into that. And this is really important too. One of the first things I tell people when I talk to them about observability is when an event occurs after the alarm goes off and you have validated that it's not a fault, or to help you actually validate that it's not a false alarm, what's the user impact? That should be the next question you ask yourself. What's the user impact of this alarm going off? And so we're going to show you how you can do this with Xray Analytics. We're going to go and troubleshoot container issues. So I'll show you, again, the app I'm going to show you is actually an EKS-based application. So we're going to show container insights and log insights and how you can dive into your containers with that service. We're going to talk about contributor insights. So I won't have an actual issue here that's triggered that contributor insights will show, but I'll show you if we were to have another issue related to high cardinality, this would help. And then lastly, we're going to end off with configuring end user monitoring. I already have a synthetic test set up so I can show you that test constantly pinging, or not just pinging, but actually hitting our page and taking a screenshot. And I'll show you how you can set up your own very quickly. So let me switch to my, my demo environment. So just bear with me. All right. Okay, let me just make this a bit bigger. Okay, so before we jump into AWS, I'm going to talk about this application. This is an application that fictitious e-commerce site for selling watches. Again, it's not very complicated. It runs on EKS. There's about 5 or 6 microservices. So as these images rotate, all the images come from an image service running on an EKS pod. So I can navigate through these. I can go look at a list of products. I'll go to my product page here. There's a product microservice that is serving up information from a catalog that is stored in DynamoDB. If I go and click a watch, I'm going to get a list of recommended watches I should also look at. There's recommendation or recommender service, microservice here as well. That's actually giving us these recommendations. If I go and buy this, there's an order service and there's a shopping cart service. So there's about 5, 6, 7 microservices here. DynamoDB, EKS, SQS is also in here for the ordering and the checkout process. So it's not a terribly complicated app, right? We're not talking hundreds of microservices here. So I just want to show you this because we're going to keep coming back to this, and everything I show, all these capabilities I talked about, will be running or based off of this application. So the first thing, again, go back to that circle of chaos there. When that alarm goes off, let's look at how we can actually use anomaly detection to improve or make the management thresholds a lot easier. So I have an alarm here, so let me go to a new tab, and let's make sure that you guys can actually, this is a good resolution for you. The people in the back, can you see this okay, or should I make it bigger? Thumbs up? Good. All right, so here's an example, basic example of CPU utilization. Everyone has an alarm on CPU utilization. What I have here, I've actually already turned on anomaly detection, but I've just unchecked this so you're not seeing it on the graph right now. But we have the CPU utilization, and you can see here, up until like just the last few minutes, it's relatively low, and then it spikes up. So when you turn on anomaly detection on the metric, what it will do, can you guys see that green band? Okay, good. So that band is basically anomaly detection. It's prediction band. And so when you've turned on anomaly detection, it's going to use machine learning and the historical metric data to generate that band. And so if it starts to see things that happen at 4 p.m. every single day, it's going to realize that's not actually an anomaly. That's part of the application behavior. And so the band will start to, maybe the first time the alarm goes off, next time it says, you know what, I've seen this before, so I'm going to adjust the band. And it's using ML models to predict that. And so why, visually, it's cool to look at, but why this is important is it really simplifies threshold management of your alarms. So if I go and create an alarm off of this, and this is where this ties into the alarming, what I can do here, as opposed to saying a static value, where I would have to specify a certain amount, and again, percentages aren't as difficult, but if you have anything that's not percentage, it's extremely difficult. You're constantly tuning these things. But with anomaly detection, I can simply say, if it goes outside the band, alarm. I don't have to worry about what that value is. It's going to use machine learning on the back end to adjust that band. So I can say, in this case, I don't care if it goes below. This is a metric where I only care if it goes above the predicted band. So you say greater than, and you can set the threshold as well. So this is just the number of standard deviations. So you can say 2, that's the default, but you can adjust this to whatever you want. It'll adjust the width of the band. It'll make it narrower or wider. So you go ahead and you set the alarm. Again, this feature will really help if we go back to that circle of chaos, the very first time, where it'll help reduce those false positives, right? It's going to take into account historical data as it does its prediction on your metrics. So let's imagine that has just actually fired off because we saw that spike at one point. If I go back to the original one, sorry, my apologies here, 1 second. Okay, there's something actually. All right, so I'm going to just go back the last few days. I'll show you where actually it is. Sorry, there we go. So there's an example where it's gone outside of the band. I've just gone and looked at a lot of data over the last few days, but you can see that spike there that's gone up and it's in red. So it's clearly breached that threshold. Okay, so let's assume that we have this configured. It's helped us reduce the number of false positives. So the next thing I said we're going to look at is dashboarding. Right? How can we use cross-account, cross-region dashboards to help give us more visibility, give us a single pane of glass into all the metrics that CloudWatch has collected across all our accounts. And so if we go to this dashboard, you're going to see a bunch of different widgets here. Our CPU utilization is showing up again, the alarm of it. So the alarm's gone off. That alarm went off 3-4 hours ago. Now we're really stressed because it's 4 hours. We still haven't figured out what the heck's gone on here. There's other things on here. We just all up CPU average. So you can, again, just showing some of the different widgets you can do here. Log insights, if you've used log insights, you can put the actual query results. So you can query your logs and put those results directly on the dashboard. We have anomaly detection turned on another metric over here. DynamoDB, which is serving up our product catalog, is also on here. But if we scroll down, we'll see this thing that says network out. And it has the little Xray in the top right corner. What that indicates is this metric is not in this account. It's actually coming from another account and potentially another region. So this would be an example where we would have an operational or application dashboard, and we may depend on transit gateway or some other thing in some other shared service account, but we want to see that data. And so here I'm actually taking that metric from that other shared service account and putting it on my dashboard in my account. And I'll show you how you do this. So let's go to settings. And you go to configure cross-account, cross-region. What you do here is you configure a role in this account that says basically other accounts can look at my metrics and my metrics, alarms, and dashboards, and you create these for your other accounts. You could do this through stack sets to simplify the deployment. And then what you do in this account as well is you specify an account selector. So in this case, I've hard-coded, the 3 options are use organizations to get all the account IDs and account names, do a custom account selector. So in my case, I would just hard-coded a pair, like an account ID and a name, or you could just leave it wide open. People could input it into a text box. But what that basically does is now I can go to my metrics, and I'll show you here. When I go to my metrics here, and you'll see this selector on a lot of different screens, I can go select my shared service account. I'm in Oregon right now, but I may want to go pull something from Virginia, and so I can go and, again, I'm just going to pick a random metric here. But I can take that metric, I'll graph it, so let me remove these other metrics we were looking at. So now that is coming from a completely different account, and all I have to do is say add to dashboard, and I can go ahead and add to my dashboard in my account. So this is super simple to be able to pull metrics directly from another account into your dashboard. So now that's showing up as another one with the Xray annotation. Okay, so looking here, we've had the alarm go off, the CPU alarm's gone off. We're still not quite sure what's going on here. It's clearly not something in that other account. I didn't see anything weird with that. So let's go, it's probably something with our application. Let's dive into our application, and let's do that using Service Lens. So Service Lens was just launched quite recently. And what this is going to show you, you can think of this as an observability service. This is helping you correlate your metrics, logs, and traces. And I'm going to just adjust the screen here a little bit. So I'm going to zoom out. And what you're going to see here is a relatively complex web of components or circles talking to each other. As I described before, our application only contains 5 or 6 microservices, and it's producing something like this. Can you imagine if you have 100 or 1,000 microservices in your application, how you could make sense of that? It's really hard to monitor and observe distributed and microservice architectures. But there's something on this that will actually help us identify 2 things. I'll point out the first thing. Do you notice how some of those lines are darker and some of the circles are bigger? We're in request mode. And so what that means is, out of all the traces it's collected from Xray, the darker the circle, the darker the line, the bigger the circle, that's where all the requests are happening in our application. So we can see here there's about 5 or 6 of these. This is the front-end service. I'll come back to this little pop-up here in a second. There's an image or catalog service, the image service. And there's a mode here where you can actually do the same thing, but with latency. So you can turn on the latency mode, and again, you can zoom out, look at from a 40,000-foot view, and understand right away where all the latency in your application is. So all these things on the left, these are just users, but the first thing these 2 users are hitting are a front-end service here. So if I mouse over, again, that would make sense that the latency starts on the front end. But the downstream component that causes the most latency in our application is our image service. So if you remember the application I showed you, it's the service that's serving up the image. So there's other information on here as well. When you have a really complicated graph like this, oftentimes you want to hone in on one service. So let's look at the front end. And so you can click an item here. It's going to pop up some metrics. I'll just bring that up right now. It's going to give you, every component you click on here is going to give you 6 things. And this is coming from the Xray data. It's going to be your latency, your requests, your faults, and you have alerts here as well. On this screen it's going to be those 3 things plus alerts. But say we want to just understand, we want to make that front end the center of the universe. We want to see what's upstream and what's downstream. So what we can do here is we'll go ahead and click View Connections, and it's going to zoom in that now. So now what we're seeing here is basically all the upstream and all the downstream on that component. This is really the center of the universe from this perspective. So we can go back here, and let's dive a bit deeper into this. The other mode here, this is a map view, but you can also look at this from a list perspective. So I click list, and it gives me all my nodes that it's drawn on there. I can see if there's any alarms. I can see the average latency, number of faults, number of requests per minute as well. So there's also that view if that's what you would prefer. So if we go back to the map view, and we look at the front end, what I'm going to do here now is I'm going to click View Dashboard. So every single component in Service Lens will have its own dashboard. I've selected the front end. It's a container. It shows me 6 metrics. You'll see these 6 metrics for every single component you click. So latency, request, fault, the OKs, the errors, and the throttling, as well as alerts. If you select something that has, for example, DynamoDB, we're using that for our product catalog, we get those 6 same metrics. We also get additional information about that service. What's the table name? How many items are in my DynamoDB table? What's my, again, key metrics for DynamoDB? So this is context aware. If we go to SQS, which is used for the ordering queue, again, we get our standard 6 metrics plus alerts. But as we go down, we're going to get service-specific metrics for SQS. So it's context aware there. So let's go back to the main view here, and let's go back to our front end. Or actually, yeah, we'll go back to the service map. I'm going to click on the front end here, and let's go look at traces. So from here, from the front end, I'm going to view traces. Okay, so we're in the trace view here. And what I'm going to do immediately is I'm actually going to jump to Xray Analytics. And what I said before, we talked through, we're going to talk about anomaly detection, how it can help with alarm management, talk about cross-account, cross-region dashboards. Now we're identifying user impact. What's the user impact here? So if I click View in Xray Analytics, this takes me to a feature that the Xray team released earlier this year called Xray Analytics. And so the way to think about this, I'm looking at the last 6 hours. I've collected almost 25,000 traces in that last 6 hours. And so think of it as a way to say, here's a set of traces, trace set A, and here's another set of traces, trace set B, and I want to compare them and try and find patterns. So out of these traces here, what I'm going to do is we're going to do this 2 different ways. The first way, imagine you have a deployment. We talked about how deployments are a lot more difficult now. Well, let's say on this graph, over the last 6 hours, we're looking at 6 hours on time series. We deploy at 9 p.m. because we always deploy after our customers go home. So we're going to go here, and we're going to say that's trace set A, everything up until the point we deployed. I'm going to click over here, and I'm going to do everything after we deployed. So we have 3 hours versus 3 hours. So now that I've done this, if you look up at the response time, what you'll see is all the traces overall, all the traces before the deployment, all the traces after the deployment are relatively the same. So what this tells us is a deployment hasn't caused this issue, right? Because post-deployment, before deployment, we're still seeing the same response time distribution. The P95 is relatively the same. But let's do it the other way. Let's try and find out, why that CPU went up, why is there latency in this application here, and where that latency is, because there obviously is some latency. So what I'm going to do now is we're going to compare everything up to the P95 as trace set A, and everything above the P95. So the last 5%, the slow stuff, we're going to compare that to that will be trace set B. So I'm going to go from here up to the P95. We'll compare this to everything above the P95. And so one thing to note, when you do this, when you start with response time, look at the time series activity. If we did this and everything that trace set B, the green, was all in like 1 or 2 blocks, what that's telling you is all your latency, the tail latency, is all one specific period in time, right? So something has happened there. In this case, it's fairly evenly distributed. So we're definitely seeing latency, the tail latency is going across the whole 6 hours. But now we have these two sets and we can start to compare them. So again, we can look at the status codes, the URLs, or this provides a lot of information right here, is that we can see these images. These are the top URLs that have more latency. You'll see this little delta icon. So that's basically saying trace set B has this URL 22% more than trace set B. And you can continue to compare these over the different dimensions. So this is like user agent. Maybe there's a user agent issue. I can't recommend enough when you do tracing, annotate this with create annotations. You can think of that as business data or business metadata. So user ID, product ID. Again, I'm looking at user ID. User ID is fairly consistent. There's not one user causing this latency. So this latency issue seems to be widespread. One other thing about Xray that's really neat is that we'll use some analytics and show you what we think is the root cause of slow response times. And so right here, it's actually saying 55% of the time it's the image service, which is in our EKS cluster. So this is definitely an area that we want to go investigate. So Xray Analytics is really good at helping you answer the question, what's the user impact? The alarm's gone off, you don't know, you're in this circle of chaos and confusion, you need to understand what the user impact is. Xray Analytics is really great for helping to answer that question. So let's go back to Service Lens. So 1 second here, bear with me. All right, so from here, what we can also do too is we can start to look at these traces. Actually, I didn't show you this, so I'm going to go back quickly to the service map. So we've been talking about latency, but there's also errors on here. I don't think if you noticed that. So if I go to the service lens, we're seeing errors. And we're seeing errors because we see colors on these circles. So if you zoom out here, you can see this circle is a bunch of orange. What that means is orange means it's a 400, HTTP status code 400. Green, sorry, not green, red would be 500s. And if it doesn't have an error or a fault, it's just going to be a clear circle. So there's definitely errors there. We're even seeing errors on the front end. So there's some 2%. Again, 2% doesn't sound like a lot, but the scale here, like we're getting an error at least every minute. So you can see the number of faults per minute, number of requests per minute as well. So 2% of all the things that hit our front end are causing an issue. So let's dive into that. Let's look at the front end here. And so I can click View Traces. And so from the front end, what we'll do is I'm going to select, you can do a bunch of filter types. So I'm going to select fault. I'm going to add this trace stats to my filter. I could do this with all these dimensions here. If I had user ID, I could go there. If I had a specific URL, I could add that to the filter. But what this basically does is it says, okay, retrieve all the traces that have the front end in the trace that have a fault. And then you scroll down here. Again, you get response time distribution of your traces, but then you get your actual individual traces here. And note the URL address. It's all zeros here, so that seems really odd. We'll take a look at that in a second. But I'm going to just click one random trace. It's collected 207. We can page through this list if we wanted to, but I'm going to go ahead and just select one of these traces. So this represents one single trace that's being captured by Xray and is displayed in Service Lens. So if I look here, I'll minimize this map legend. Client hits a front end, we see red. That's a 500. Downstream, the catalog service returns a 400 error. So if we actually look into this, and we could click on each of these circles and get more information about that. But what we're seeing here, if we go down to the actual timeline, what we're going to see is the front end is erroring out because the catalog service returns a 404, which is not found. And if you looked at the URL before, we saw a bunch of zeros. It seems like an invalid or bad data basically in our product catalog. So this helps us, Xray Service Lens helps us diagnose in our application and our services the cause of latency, helping you identify performance and also helping you identify what causes errors in your application. It's really hard in microservice architectures a lot of the time to understand what downstream is contributing to a bad user experience. So let's dive a bit deeper too and go into container insights and see if there's anything that's contributing to this in container insights. So I'm going to go back and I'll highlight, I didn't actually highlight this before, but on the service map we also have context here. So if I go on the front end, this is running on a container, and you'll see that there's a link here to bring up container insights. So we're adding more and more deep linking between all these capabilities and services between CloudWatch and Xray here. So from container insights, now what we're looking at is my EKS cluster. We get metrics and logs. And this was released a few months ago. I have a tech talk out there from August that dives really deep for an hour into this, so you can go and take a look at that on YouTube. But just to dive into this quickly, we can go in, again, at the cluster level, great, we get memory CPU. We can get that from EC2 if we want to. But I can dive into the individual pods, so I can start to looking at my CPU per pod, my memory utilization per pod. I'm going to go directly into a service. And let's go look at the image service, because that was causing some latency there. So, and sure enough, what we're seeing actually here, when we look at that microservice, oops, my apologies here with my mouse. What we're seeing here is that image service is one of the top things there. So from the image service, these are the key metrics here. And then what we can do is we can actually look at the application logs off here as well, because we have container insights installed on EKS. This EKS cluster is pulling these metrics and logs and traces off. So from the image service, I'm just selecting those two pods. I'm going to say view application logs. These will bring back some logs that we can take a look at. And so like an example of this log, I have that saved over here. So this is log insights. Again, this was launched last year. There's lots of videos if you want to dive deeper into this, but it allows you to do log diving, log analytics across your CloudWatch logs. So imagine we have, so what this has basically done is we run this query and it's bringing back all the logs from container insights for our image service on those two pods. And so we're getting all these logs, we see a distribution over time series, and we can actually dive deeper and start looking for errors within here. We can look for errors, we can basically count the number of errors and do an aggregation and say, I want to visualize this, how many errors showed up over 5-minute buckets over like the course of 12 hours or a day. So you can understand where your errors are actually distributed over time as well. So again, we're not going to dive into this too deep here, but I just want to let you know, Service Lens is integrating with these other insights tools that we're releasing as well. So we could dive into here and we could try and find errors here. In this case, there's not any errors, so we'll move on from this. The one other thing I'll call out, and this is actually an example of embedded metric format. We actually have the application, or the logs, the performance metrics that you saw in the dashboard before, those are actually logs. They start off as logs coming from Container Insights. So if I go into my performance logs here, and let me just run, actually I'll go back a screen. Let's look at the performance logs for our 2 image services on our pod. So we run this. What you're going to get is actually the log data, or sorry, the metric data coming off our container as a log. So we could go to log dive on this, we can do aggregation, we can look at all this historical data and write queries against our metric data that's stored as a log. So we could go into here, and you're going to see things such as like the number for that pod, how much network traffic, bytes dropped, errors, packets. You get all that information there. And all that is also represented as a metric. So if I look at the metrics of Container Insights, you'll see the same thing. We'll see Container Insights, we'll see our pods, and the file system utilization. So EMF, embed metric format, gives you the best of both worlds. You store your metric data as a log, ingest it that way, and tell EMF to turn certain portions of that, subset of that, into an actual metric. So you can have metrics, you can have alarms. You can think of it as a more advanced metric filter, basically, if you've used metric filters before. It's a really slick service. So that's Container Insights, but let's talk about Contributor Insights, because that was the 4th thing that we launched recently. So again, this is not going to uncover any issue here. The issue is definitely the image service. So at that point, I would go talk to the developer that owns that and say, you know, you have an issue here, we have to fix this. But let's look at Contributor Insights. So imagine we have web server logs that we're ingesting into CloudWatch. What I said earlier is Contributor Insights is really good at identifying high cardinality, or events with high cardinality data. So if you have hundreds of thousands of things or millions of IP addresses, it's really hard to visualize. You can't visualize that on the widget, on the dashboard. So as you ingest your logs, you create these rules in Contributor Insights. Now this isn't, I haven't generated millions of things, but I have my VPSee full logs turned on. And what I've done is I have a rule in there that looks at the VPSee full log. And again, CloudTrail is a great log to use this with as well. But what I'm doing is I'm saying my source IP in my VPSee full log is a contributor. And so what it's doing here, it's actually found over the last period, I'm not sure what the time range is here, the last 3 hours, 598 unique contributors. If I were to try and put 598 things on a widget right now, you couldn't make sense of it. But what this is doing is it's going through the VPSee full logs and it's telling me what my top contributors are. So I can clearly see here that this is the top contributor and it's spiking throughout over this time series here. So this specific IP address is generating a lot of traffic within my VPC. So this is a really powerful feature when you combine it with CloudTrail logs, VPSee full logs, and really any other type of log that has high cardinality type of metric type data in it. And then what you can actually do with this, you can go look at the source logs. We can actually add this to our dashboard. So the dashboard that I showed you earlier, or operational dashboard that we started with, you can go ahead and add contributor insights to that. So we can take a look at that. There's even metrics here of contributor insights. So if we go, let me scroll down here, or go back to contributor insights. If you've ever used metric math, it's much more than just math. It's expressions that allow you to create new metrics. But if I go, let me take a look here, view metrics. So number of unique contributors. There's a series of these insight rules, basically. I'm going to get rid of this one here. So this is basically showing you where the number of unique contributors to that insights rule over time. And there's a little helper here, the math expression, where you can actually get some other ones. Let's see, filter. So the insight rule metric is here. And if you look at our documentation, you'll see the other options. But from contributor insights, we go back here quickly, you'll see some other ones. So what's the max contributor value over time? So at any given time, what was the max number of contributors I had at that specific point in time? What's the sum, the average, the max? So you can plot all this as a metric as well. All right, last service. I know there's a lot of capabilities here. So this one's really cool too. These are all cool, but I really like synthetics. So we talked about how we're going to simplify thresholds with our alarms, how we can use cross-account, cross-region dashboards to help get more visibility across multiple accounts. We use Service Lens. We looked at Xray Analytics to define or understand user impact. I showed you contributor insights, container insights, log insights. Let's look at synthetics. Let's set up a test that shows us how we can actually identify when there's an issue, or help us hopefully detect problems before our actual customers find those problems. So synthetics, I have a canary that we call them canaries. That's a test. So actually I have that in a completely different region. So let me pull that up. So I'm going to open up a new tab here. So I have the app I've been showing you is in Oregon. This canary is in Ireland. And so I have this canary. It's called a heartbeat test. And you'll see it executes, let's see here, every 15 minutes or so. And if I go into this actual canary, I'm going to see all the test runs. I'll show you what a test run looks like. So as I go through here, you'll see all these, oh sorry, this is actually running every single minute. So you're seeing these run every single minute. I can click on each individual one. And what you're seeing here is a snapshot. So this canary test has actually hit this page, and this is the page I showed you at the very beginning of my demo. It's gone to this page, takes a screenshot. That's all it's done. It's just a heartbeat. It's saying, am I alive? Am I getting the actual page back? And it goes beyond, I don't have to state the obvious, it goes beyond just expecting a request. It's actually loading the page in a Chromium-based instance. So if you ever actually, has anyone used Puppeteer before? Selenium, are you familiar? Same type of thing. So this is actually, you write Puppeteer scripts, and if you looked at the scripts that the wizard generates, which I'll show you in a second, they will look like Puppeteer scripts. So if you're familiar with that, you can apply that pretty easily into here. But it's taking a screenshot, but we can do much more advanced workflows. We could buy things, take screenshots along the way, and making sure the whole thing doesn't error out. So it takes a screenshot, there's logs. This is the really cool feature, is it actually stores a HTTP archive file. So we can go into here, and we can look at all those other assets that actually get downloaded, right? Because latency is not just the request and the response coming back, it's all those other things, the CSS, the JavaScript, that have to get downloaded. So I can see here, this app uses Bootstrap. So it pulls back the Bootstrap CSS. This is also pulling back other things as well. So I can go look at the headers, the response, the request headers and the response headers. And then what I can actually do here is I can actually start to mouse over each of these. Now you're even getting information about how long was stuff blocking on the client side, what was the time it took to do a DNS lookup to even get to that resource, what's the amount of time it took to connect, sending its request, getting the response back. So you get really granular information in all these tests. And then you also get logs here as well. And you can set thresholds on these, so if a bunch of these fail really quickly, you'll get alerted. Canaries actually produce metrics, so you can actually put the performance of these tests on your own dashboards. And you get some of those metrics showing up here because it's using Lambda in the back end. To run these tests, you're seeing, again, getting plotted basically against time of all these different tests and where they're falling in terms of their duration, number of errors that these Lambda events are potential throttling or invocations or errors within the Lambda function. And to set one of these up is really simple. You don't have to do a Puppeteer. You could just go create a new canary, and we have a series of blueprints for you. So I did a heartbeat. I just had to give it a name and a URL. And it will go load that URL, take a picture, and I'll give you exactly what I just showed you. If you have APIs, you can use this against APIs. You can say, here's the method, here's the endpoint, here's the payload I want in the request. And that will, again, as you fill in those fields, it will adjust the script here, which is using Puppeteer. Broken link, if you want to go check a page and see, I think it does the top 20, it pulls 20, but it'll look through all the links on the page and then actually validate. Those bring back responses. If you know the IDs of all the elements in the HTML DOM, you can start using the workflow builder. So you put an endpoint in here. You can say, I'm going to click on ID, maybe it's element 123. I want to verify that text exists somewhere in element 456. And then I want to go ahead and click with navigation on button 123. And this, as you're doing this, you're building this workflow. It's actually just adjusting the script here. But you can actually create your own script, upload that. You can store -3, and you can import them from there as well. And so as I was doing that workflow builder, what you're seeing here is it's actually each step that I added is going to take a screenshot along the way. So we could take our whole checkout process. We could add that watch to the cart, by the watch, and take a screenshot along the way and actually have that as a record in each Canary test. And then you can say run this manually, or you can run it every minute, every 5 minutes, or once an hour as well. And you set retentions and thresholds as well. So let me switch back to my deck. So we did the demo. So I just want to recap what I just showed you, because I know this was really fast-paced. We covered a lot of things here, but there's a lot of new capabilities I wanted to share with you from CloudWatch and Xray. So what I showed you to do, or what I showed you how to do, configure alarms with CloudWatch anomaly detection to help you improve false alarms, reduce them, and simplify threshold management. I then showed you how to monitor resources from other accounts. So if you have multi-account architecture, you can pull those resources into your dashboard and your account to visualize that. We then dove into Service Lens to look at our application, to visualize the service performance. We identified issues with an image service where there was latency. We figured out there was some bad metadata in our product catalog, also through Service Lens. So we were able to look at the cause of errors as well as the cause of latency. And Xray Analytics definitely helped with this, really help us understand what the user impact is. We then troubleshoot container issues, or showed you how you could troubleshoot container issues. So we dove into the container that was hosting the front end. I went into log insights and showed you how you could look at the application logs, do your log diving, but also look at the performance logs that we ingest and turn into metrics. And as an example of embed metric format, we also then talked about contributor insights. So if you have high cardinality data, this should be a key tool in your toolbox to help you understand what are the top contributors when you have high cardinality, such as web server logs, IoT logs, anything with high cardinality. And lastly, we configured end user monitoring with CloudWatch Synthetics to help us provide early detection of issues and understand what the user experience is. So really quickly here, clicker's not working. So my call to action to you guys is I have a workshop. It is waitlisted, but they usually hold back 25%. If you're really interested in getting hands-on, please try and attend this. So we'll get hands-on with all these tools. And so the time and date there and the location. Start using these tools in your account today, these observability tools. Those are the two getting started links for CloudWatch and Xray. Just a quick plug about our customer enablement, AWS IQ and support. We have a really rich set of resources to really help you guys, enable you guys to build applications on the platform. I want to thank you so much. I know it's late in the day. Please, please, please fill out your surveys. We're a metric-driven company. We really need this data. Metrics. Thanks, guys.